Hey, Lidcode fam, let's do 700 search in binary search tree. And yeah, if you know the properties of binary search tree, then you'll understand the root will always be a value. And the thing is that all the nodes to the right of any node will be of greater value, and all the nodes to the left of any node will be the smaller values. And that's how binary search tree works. Yeah, for example, look at this: 7 is greater than 4, 2 is smaller than 4, 3 is smaller than 4, and 2, 3 is smaller than 4 but greater than 2. And yeah, 1 is smaller than 2 and 4. Yeah, that's how binary search tree works. The root will be like the middle value, and every node to the left of the root will have a smaller value than the root, and every node to the right of the root will have a bigger value than the root. And yeah, again the question is asking you to check if check if the given value exists, and if the given value exists, then you have to return the entire subtree, or else you have to return just the null value. I think yes, if there is no node, then you have to return null. Again, the question, if you know how parent search works, then it becomes pretty straightforward. So I have a helper function. This can be done using recursion and iteration, but yeah, I do a lot of iterative solutions, so let me switch it up and do it recursively this time. Define a helper which will take the node value, and yeah, return the helper of the node value, which is actually the root value. And yeah, there is one thing in Python is that inside a function you can define another function. In Java and all you can't do that. You have to define it in a separate outer function itself. But since this function has been defined inside the binary search BFT function, it will have access to the val variable and all. So there's no need for us to send it also. Yeah. So if not node, that means that the value could never be found. So return none, else if you found the node and the node dot value become equal to the value, that means yeah, the node was found. So return the node, else if what happened is, yeah, you are checking the node dot value. Yeah, see, you're checking for 4, and imagine you're searching for 1. So node dot value became greater than the value which you're checking for. That means yeah, think you have to go left. Understood? Like yeah, 1 is smaller than 4, and since the binary search definition goes that root will be the middle value, and yeah, element smaller to the root will be on the left, and since 1 is smaller than 4, you have to go left. So so what you have to do, return the helper on left, else it was greater. So yeah, believe it or not, this is the entire code. Let me just try to compile it once. GL, yeah, it's not heller, it's helper. Yeah, it works. Let's submit it once. Yeah, it's pretty efficient. And yeah, wait a minute. Okay, I think there's no need to even define a helper function over here, because yeah, we can directly hijack this function to do the work, dirty work for us. So what you can do is, so if yeah, if the root itself became equal to none, then yeah, let's make it more classy. So if you could not find the root, then return none, or else if root dot value became greater than the value, then return, yeah, since you are calling this function which is inside the solution, you have to annotate it self dot bst. Yeah, now you have to go left, so left with the value. Okay, I forgot to check if root dot value became equal to value. So root value became equal to the value, then return the root itself. Else the return the set root dot search bst of dot right, and yeah, this should also work. Yeah, it works. Yeah, see, I just hijacked this function itself and I kept on constantly changing the root value. So yeah, that's how we can do it using iteration. And yes, yeah, if you want, you can also use a while loop rather than recursion. Okay, why not? Let's do with that. While root exists, yeah. While you don't have root, that means you cannot find the value. So return none. Or else while root exists, what you have to do? If root.val becomes equal to val, then return the root itself. Root.value became greater than value, then we have to go root to the left. Yeah, else go right. Yeah, this is like kind of a binary search. This is how you do iterative solution. And yeah, if you know how to do recursively, then doing it iteratively will directly come to your mind. Yeah. So yeah, it was pretty straightforward. So yes, thank you. Run more DC, you can do it.